channel, and today I'll be showing you how to program this CNC printer I made with the Spike Prime. So let's get on to it. This is a CNC printer that I made using the Lego Spike Prime. Let's see how it works. Now before I show you guys the code, I will show you how this CNC printer machine works. So this CNC machine totally depends on these two motors to work the entire system. The first motor helps the marker to go left and right when drawing the width of the rectangle. When this motor runs, it helps this wheel to move, which is connected onto this tiny wheel, which ultimately helps these two to help the paper go forward and back. The marker is still, but the paper goes forward and back. And that's what those two motors do. In the original instructions of the Lego Spike Prime building instructions for this CNC machine, it tells you to spot a mistake and the reason why when you run the code it doesn't work perfectly. This is because they have left out this part over here. If you leave out this part, the machine will go like this, and we want a perfect rectangle, which is why we will secure this. I've also added a little tweak over here. If you put a marker and it's too heavy and it's causing it to tip over, now it won't tip over like that. When you add this, it'll help it to go straight. It'll help it to straighten up so that it will work smoothly. And this is the Prime Hub. So now let's move on to the code in Scratch and Python. Okay guys, so here I am on the Spike app, and there are two types of code that I've written. First is they're the same exact thing, but one is in Scratch language and the other one is in Python. The name of this unit plan is called Broken, and you can search it up on the Spike Lego app or website. Now I will explain to you the code. So first, when the program starts, A, which is the motor that helps it go forward and back, they are both, and C, they are both set to the same speeds. And this can be any speed you like because just as long as it works correctly, but this is the speed that I prefer. First, A will run counterclockwise for 1.5 seconds. This is because when they start the rectangle, they need a head start on the top left corner so that they can begin the rectangle. Next, you wait for 1 second, and this is the whole rectangle part. So first, they continue like a pattern. So first we have A, and it runs just clockwise for 200 degrees. So, and then C runs clockwise for 575 degrees, and A runs counterclockwise for 200 degrees, which means it's going back to finish off the rectangle. And then C, which runs counterclockwise for 575 degrees. Now the same thing is written in Python, so we are importing everything even if we're not using it. And then first we're initializing the motors. So we connect all the motors. So motor equals motor in capital A, and make sure to put these quotes. And then motor 2 equals the second motor, which is C. And now we have the exact same code, and the start when program starts, that's already in here in the default program, so you don't need to worry about that, because this part is all the default one and you'll automatically get it. So this is the main part, because this is the exact same thing that we did in Scratch. And so motor is motor A, which is the exact same thing that we did here, motor A, and we're just setting the speeds right now. So the speed will be this part, all of these ones, and then it runs for 1.5 seconds, and we wait for a second over here, but first you have to import wait for seconds, because we know, so that we're letting them know that we're bringing in that function. Then we make the rectangle, which is the motor A runs for 200 degrees, then motor, and it's still at 10 speed, then motor 2 runs for 575 degrees, and the reason why to tell if it's clockwise or counterclockwise is that you're putting everything in positive, but for negative, which is counterclockwise, we're going to put a negative on the x value, which is our degrees. So this is negative 200, and this is negative 775, just like we did here, counterclockwise for 200 and clockwise for 575 degrees. And that's all for the code. So that was all for today's video, and I hope you enjoyed. Make sure to like and subscribe and turn on the notification bell. Bye!